post it on the Google Classroom now?
I got a notification.
I have to try it.
Do you have any crackers? Like those crackers you gave me the other day?
We're on TV now, so you gotta be quiet. Okay, whose turn was it? Morgan, please go.
I just.
Well, you just did, I thought.
I just did 3. It's Hannah.
Hannah.
Oh, you just did 4.
I just did 2.
You just did 4, Jada. You're on 5, Hannah.
I thought you did 3.
Jada
I
did
did
3.
do 3.
Yes, go, you number 4, please, Hannah.
Calculate the magnitude of the horizontal and vertical components of a vector that is 100 units long and is oriented at 45 degrees.
What did you put for that, Morgan?
70.7 units.
Right, we just use the Pythagorean theorem again, this time with, we're calculating a side length. And since the side lengths are the same, since it's isosceles, we can just calculate one and it goes for both.
Yeah.
Go on, Jada.
Calculate the resultant of a horizontal vector with a magnitude of 4 units and a vertical vector with a magnitude of 3 units. How does the resultant compare when the hypotenuse of the right angle has sides 3, 4? So then the hypotenuse is going to be 5 because of the Pythagorean.
Because of the 3, 4, 5 right triangle, right? Good. These are good things to know about for you to know like the concepts behind how vectors are added, but you won't have any that are 45, 45, 90 right triangles on your test. So you need to make sure you can still do the trigonometric method, which we've been practicing. Hannah.
Good number. Calculate the resultant of a horizontal vector with a magnitude of 4 units and a vertical vector with a magnitude of 3 units. How does the resultant compare with the hypotenuse of a right triangle having sides of 3 and 4 units? Well, whoever had this book wrote 5.
Yep.
So 3, 4, 5.
Yeah, it's a 3, 4, 5 right triangle, and so it has the same, right? So that's the point, is that if it's a right triangle, any of the Pythagorean triples we can use to calculate if they're added together, but only if they're added together at right angles. What do we have to do if they're added together at angles that are other than right?
And we use some old hippie.
Yeah, we use
Another hippie.
trigonometry. We use trigonometry, and we break them down to their components, then we add their components, and then we build a new triangle that is a right triangle. Morgan, move on.
7.
Either 7 or 8.
I did 7.
Okay.
What are the horizontal and vertical components of the 10-unit vector that is oriented 37 degrees above the horizontal? And I said horizontal is 8 units.
Okay.
Is that wrong?
No, you're right.
And the vertical is 6 units?
Right, because this is a
37.
37-degree triangle, which is a 3, 4, 5
Yeah.
right triangle. Yep.
My dummy had just the horizontal.
Well, that's okay. You know now, right? Did anyone do 8?
No.
Well, maybe one of the people who will watch this, because there's no one in it right now, might have. So, because what are the horizontal and vertical components of a 10-unit vector that is oriented 53 degrees from the horizontal? Well, it's the same. It's still 3, 4, 5 right triangle, except now the long side is opposite the angle, right? So it's going to be 6 units for the horizontal and 8 units for the vertical. And then number 9,
You
Jada.
can explain.
Okay. The launching velocity of a projectile is 20 meters per second at 53 degrees above the horizontal. What is the vertical component of its velocity? Neglecting air friction, which of these components remains constant throughout the flight path? Which of these components determines the projectile's time in the air?
Well, so in the future when we have these multiple part questions, why don't you read the question first and then say the answer for that part and then go on to read the next question. But that's okay. So go ahead and answer the first one.
So the launching velocity. What is the vertical component of its velocity at launch? Its vertical component. What's going on?
Yeah, it's looking for a numerical answer. What is the numerical
Oh,
answer? You know,
9.
No, not 9.
9.81.
No, you're thinking about the acceleration, but it's talking about velocity. Did you calculate this one, Morgan?
20 meters per second.
That's its resultant velocity, but we're looking for a component. So since it's 53 degrees above the horizontal, let's just see if we can talk through it. Since it's 53 degrees from the horizontal, it's going to be a 3, 4, 5 right triangle, right?
Mhm.
And since it's 53 degrees, the vertical component is going to be the longer. And so since it's 20 meters per second, it would be times 4/5. So 20 times 4/5 is 16 for the vertical, and for the horizontal, it's going to be 12. So visualize in your head 3, 4, 5 right triangle. If the hypotenuse is 20, then each of those basically is going to be multiplied by 4. So the 4 side, which will be opposite the 53 degrees, which in this case is vertical, is going to be 16 meters per second. And then the 3 side, which will be horizontal, is 12 meters per second. It says, neglecting air friction, which of these components remains constant throughout the flight path? So what's the answer to that?
Kaylin said it's not working for her, but how they got it to work.
Yeah, I'm trying to figure out how to do it. It's not.
I have one, the link itself isn't working. They said she had to make an account.
Every
and then
time
they
I
said that
clicked
the
on
link isn't
the thing,
working
I
fine
had to
for
create
me.
an account, and then it just takes me to like me live streaming and not your live stream.
Oh, I must have clicked it wrong.
So I don't know.
So where do I find the... What's this?
We lost the
Oh, there it is. I just typed in the wrong link. They should try now. I edited the link so that... There we go. Tell them to try it now.
Man. I said that
Okay,
you're
it's lucky
sending
you
it.
voted it, you edited the link at 11:11. It's gotta be lucky.
Yeah, well, we could sure use some
Yeah,
luck in
that's
the
okay.
YouTube department.
Why?
What's this little button do? Mute. If that mutes it, what's this button do? It's like a green dot and then 5 not green dots. Okay, someone's in it, so that means everyone can get in it, so that's good. Okay, we're moving on. Let's do number, think and explain. Let's do number 1. Who did number 1? Number 1 reads, what is the maximum possible resultant of a pair of vectors with magnitudes of 4 and 5 units? So the maximum possible result would be 9 units, because if they were lined up exactly right. And what's the minimum possible? Well, if they're exactly opposite each other now, it could be
Oh no.
1, right? If they're exactly opposite, then it'd still be 1 unit, because 5 minus 4 is 1.
Sounds good.
Who did number 2? You were to do 2 of these, so did you all just do 3 and 4?
I don't remember which one. I did 2.
I did one. I think
2 reads.
I did 1.
Jada.
If you swim in a direction directly across the river and you end up downstream due to the flow of water, do you move faster than you would if the water didn't flow? Explain. I said no, the hypotenuse is the longest side traveled.
Okay, the hypotenuse is the longest side travel, but you're going along. Can you ever have a negative result? Hey, Talon, excellent question. Talon is in the live chat spitting out great questions. Yes, you can have a negative resultant, but so the negative in the capacity of a velocity would just mean it's in the opposite direction of whatever the one you had as positive. So like if you had the 4 and the 5, I don't know how to make 5. Here, I'll do fingers. 5 and 4. If you had positive 4 plus negative 5, right, you'd end up with negative 1. But that would just mean that it's in the direction opposite of whatever the 4 was. So 4 right plus 5 left will give you negative 1 right, which is the same as 1 left. I know it's not
That's
the best.
hilarious.
I know it's not the best illustration, but so briefly, Kaylin, the answer to your question is yes, you can have a negative resultant. The longer explanation, I did my best. So back to your question, Jada. If you swim in a direction directly across a river and end up downstream to the flow of water, did you move faster? Yes, because you're the horizontal component going across the river, just you're swimming, and the vertical component is the river pushing you down. And so you're moving slightly faster because the hypotenuse of that triangle is longer than the sides.
Because water's flowing like this, fighting the current.
Yes.
It's gonna take more time than when you just follow the current. Well,
But you're not fighting against the current. You're just going across horizontally. So the river's flowing. I'm trying to do this for the camera too, but you can see it too, right? River's flowing, we'll say down. You know how to do. River's flowing down. You're going to go across the river this way at a right angle, right? So if the river wasn't flowing at all, you'd go at speed X, right? And if you weren't in the river at all, it would go at speed Y, right? But where you're trying to swim across and it's pushing you down, you're going at slightly faster speed, h, the hypotenuse. Yeah, so yes, the answer is yes. Yes, you're moving faster than you would if there was no flowing water. Number 3, who did 3? Morgan, would you read it, please, say the answer?
The speed of falling rain is the same 10 meters above ground as it is just before it hits the ground. What does this tell you about the weather or not the rain encounters air resistance? So I said like it's the exact same, that it's going to be 10 meters.
Right. So if it's still going the same speed it was when it was 10 meters above the ground,
It's going to be cool.
is it accelerating?
No, it's
No.
constant speed.
It's a constant speed. So what, do you remember what must be true of the forces acting on it if it's a constant speed?
Air resistance.
Yeah, there's air resistance counteracting gravity, right? So there's the only forces acting on it are balanced, air resistance and gravity. We call that, something velocity.
Rotation. Constant velocity.
It's not floating, right? It's still moving. It's just at a constant speed. It is a constant velocity. But we specifically call this, when gravity and air resistance balance out, terminal velocity. We call that terminal velocity. Number 4 says, rain falling vertically will make vertical streaks on a car window. However, if the car is moving, the streaks are slanted. If the streaks from a vertically falling rain make 45-degree streaks, how fast is the car moving compared with the speed of the falling rain? Well, it must be
65 miles an hour. Because that's the legal speed.
okay. So yeah, if we
45,
assume the car is moving 65 miles an hour, then the raindrop must also be moving 65. But the point is they have to be the same, right? So if the streaks are at 45 degrees, then the velocity of the raindrop and the velocity of the vehicle must be the same velocity, right? Because 45 means it has the same legs of a triangle. Still doing good in the live chat. Okay, we're now on number 1 of 5 through 8. Which one did you do, Morgan? 1 of 5 through 8. Which one of 5 through 8 did you do?
I think my things are written down wrong, but probably the first one.
So you did 5.
Yeah, I think so.
And Jada, which one did you do?
I did 5.
You did 5. Which one did you do? And I assume one of you guys did something. 5 reads, Morgan.
You're driving behind a car and wish to pass. So you turn to the left and pull into the passing lane without changing speed. What does the distance increase between you and the car you're following?
Jacob?
Okay. So you decrease your velocity by changing directions, which slows you down
Yes, but
compared to your car.
yeah, more specifically, right? You had velocity y going towards the car, right? So this is
And then when you go
up, right? When you turn, now your velocity is the same, but now it's the hypotenuse. So the y component of your velocity must be lower than what your velocity was before, right? And so it seems like you're slowing down. Your car's still going the same speed, but now it's at an angle, and so only the y component matters for how much it's moving forward. So you might never pass that, dude. Let's do number.
It's like when you split
1.
off like in an exit, when you come to an exit and you take it and you
Yes.
watch the car.
Also, you do have to slow down because the speed limit's lower there, but so there's other things at play. But yes, that's one.
Not in all exits.
Not on the highway.
Well, maybe not a really
Yeah.
fast exit. Number 1. Jacob, or Hannah, it's your turn.
Okay, number 1. Things fall, right?
Yes.
A boat is rowed at 8 kilometers per hour directly across a river that flows at 6 kilometers per hour as shown in the figure. A reads, what is the resultant speed of the boat?
So they're at right angles. So this is a right triangle, right? And if the legs of the right triangle are 6 and 8, what must the hypotenuse be? 8. So it's kind of like a what kind of triangle?
10. Well,
10 is the
3,
answer.
5,
It's like a 3, 4, 5 right
Yeah.
triangle, except they're double. So it's a 6, 8, 10 right triangle, but 10 is not the whole answer. 10 kilometers per hour. Okay, 10 kilometers per hour. Morgan.
for 8. 2.
No,
B. B.
B.
How fast and in what direction can the boat be rowed to reach the destination directly across the river.
Wait, Taylor, are you saying number 9 because you want us to do number 9 from the Think and Explain? Oh, or she retracted the message. Yes, do number 9? I'm sorry, Morgan. Oh, I just noticed that. Well, we'll see. Carry on, Morgan, for now. Harry, or no, were you doing B?
Mm-hmm.
Go.
I already read it.
Oh, okay. So,
It's okay. How fast can the direction? In what direction can the boat be rowed to reach the destination directly across the river?
Okay, so the river was 10, so I don't really know actually.
the river was
10 kilometers per hour at 45.
almost 10 kilometers per hour. Oh, Taylor says, I dropped my phone and I sent 9. Okay, that's fine.
I thought
it's-
10 because we just saw.
It is 10 kilometers per hour, but it's 37 degrees because that's the side of, that's the short angle of the 3, 4, 5 right triangle. Okay. Harry accidentally falls out of a helicopter.
Okay, no.
It's traveling at 100 meters per second, which is 1 football field every second, almost. He plunges into a swimming pool 2 seconds later. Assuming no air resistance, what is the horizontal distance between Harry and the swimming pool when he fell from the helicopter? Just the horizontal distance. Almost, he fell for 2 seconds.
200.
200 meters, is that what you said?
Yes.
200 meters is correct, because he fell for 2 seconds. His horizontal velocity is still 100 meters per second, even though he's in an airplane. Or even though he was in a helicopter, moving 100 meters per second, right? This is how fast 100 meters per second is. He was in a helicopter, he falls for 2 seconds, so he's still moving 100 meters per second. For 2 seconds gives him 200 meters. Okay, 3. Harry and Angela look from their balcony to a swimming pool below. Harry's a thrill seeker. Falling out of helicopters. Oh, I guess that was an accident, so maybe not a thrill seeker, just unlucky. Harry and Angela look from their balcony to a swimming pool below that is 15 meters from the bottom of their building. They estimate the balcony is 45 meters high and wonder how fast they would have to jump horizontally to succeed in reaching the pool. What could we do? Did you do this one?
Oh, which one is this? Is this 3?
This is 3.
3. 3? I got 5 meters per second. I don't remember.
You did. How did you do it?
On number 3.
You don't remember because you didn't show your work, even though I specifically asked you to. Here's what you do. Let me tell you what you do. You find T using the equation D equals 1/2 GT squared. So you know your height, which is 45 meters high, right? Remember D equals 1/2 GT squared? That's how far something falls in free fall. Remember that?
Yeah.
D equals 1/2 GT squared. We solve that for T, giving us T equals the square root of 1/2 D over G. Remember? So we put all our numbers into that. So we get 1/2 times 45 divided by 9.8 meters per second squared. Square root of that whole thing gives us 3 seconds. Nice. Or about 3 seconds. And then, since velocity is 15 meters divided by the 3 seconds from the y component, we get, as Jada said, 5 meters per second. So, just to say the steps as words, the first thing we need to do for number 3 is find time using the d equals 1/2 GT squared equation and the y or the y distance. Then we plug that time in to the x distance, and it'll give us the velocity we need, which is 5 meters per second. Questions?
No.
There is one almost just like this on your test, so make sure you're able to do that one. And then one of 4 through 6. Which one did you do, Morgan?
I think I did 5.
You think you did 5. Which one did you do?
Yeah, I did 5.
You did 5. Hannah, did you do 5? I'm going to assume that you guys did 5 too, unless you tell me otherwise. So 5 says, the boy on the tower. There's an image in your book of this. The boy on the tower in the figure shows a ball, throws a ball a distance of 6 meters as shown. At what speed? 6D meters, sorry, thank you. 6D meters as shown. At what speed in meters per second is the ball thrown? So we do the same thing as we did in.
Because 60 divided by 20.
Did you say 30?
Yes.
Yeah, 30 is the right answer, but not because of that. 30 is not 60 divided by 20 either. Did you say the answer is 30 or you say 3?
I said
It doesn't matter. The answer is 30 meters per second because we do the same thing we did with number 3. We find t using the distance that's given for the height of the tower. So t equals 1/2 gt squared. Manipulate. So t equals the square root of 2d over g. And then that gives us our time. And then we divide that time into 60 meters. So 60 meters divided by, it ends up being 2 seconds, gives us 30 meters per second.
So
I'm going to leave the live chat open for 1 more minute. If you guys have questions, I mean, we can keep it open as long as you need. But if you guys have questions, please ask them within 1 minute. And then you guys, do you have questions? I don't know if you do or not. You say no, but I don't know if that's true. I haven't exactly decided how I'll do the test. It will be tomorrow. I think what I'll probably do is give it to you guys by paper and then also post it online as a Google form so that you 3 can take it online as a Google form.
You know how easy it is to cheat on those? That's so
Do you know how hard it's going to be to cheat on? You're going to use your notes, which is going to be better than anything they can find online, I guarantee you. They're also going to use their notes. You're going to use your notes. You're going to use your notes. And these questions are all going to be made up by Mr. Kyman. So if you type in the question on Google, it's going to say, I don't know what's going on. And then you're just going to learn it by yourself anyway. And then all the ones that you could have found online, you have a better version of online right there in your notes because it's tailor-made to what you need. And Jada, if it ends up not working out, we'll do it different in the future. But this is my plan. Are you guys good? Or I guess it must, I don't know if Hadley's even in it. Is Hadley in it? Participants. Just me. Where's the population? Is there a way I can see who's here?
They probably left since.
Okay, bye.